Hi buddies, okay, welcome to MANOJ Masterclass. All students, all of you, I think the most difficult subject, maths and science. And due to lack of basic concept, what happens, you used to memorize the subject and used to write in the examination. So in the board exams of class 10 and 12, you used to get marks, maybe 90, even 95. Okay, but what happens whenever it comes about the competitive exams like NEET and JEE, you can't succeed because you don't have the basic concept. CBSE or SEBA doesn't matter, concept is always concept. So try to understand the subject, then only you can succeed in NEET, JEE like competitive exams. So don't run behind marks. So I will try to give you the ground zero concept of these science and maths classes. So today I will start the first lecture about science of chemistry. Okay, chemistry will start by the configuration of atom. Okay, in our first lecture we will try to learn the basic concept of chemistry. Okay, chemistry is the science beyond our naked eyes. That is, it is the science of microscopic objects. Whatever we can't see, that is chemistry. Okay, before that, we will learn about three things: mass, charge, and force. Okay, let's start with the concept ground zero report of mass. Let's start with mass. Everything of this universe, whatever, like me, you, pencil, pen, whatever, they have mass. Everything has mass. Okay, there are some objects that doesn't have mass also, like photon, it doesn't have any mass. But most of the objects have mass. Okay, so mass we measure in kilogram. Okay, the unit, SI unit of mass is kilogram. Okay, what do you mean by SI unit? Okay, actually we have units like when we measure mass, we used to measure in kilogram, gram, centigram, milligram, like that. Okay, so even we used to talk about this aqua, dopua, like that we used to talk about that. Even in England they used to talk about the mass of like pound, ounce, like that they used to talk about that. So everything has different system of unit. So whenever the scientists, all scientists gather together, they used to have problems while communicating because somebody uses kilogram, somebody uses pua, ekpua, dopua, like that. Okay. So why they have decided to take a universal unit for mass. So they have decided to take kilogram. The universal unit, which one is taken globally, that is called SI unit. Okay. So SI unit of mass is kilogram. That means we measure mass in kilogram. Okay. So when we write down the mass, we write in two ways, especially in science. How? 2 into 10 kg, or we write 2 into minus kg. This is the standard way of writing numerical values in science. When you see the power of 10 positive, then you should understood that object is more bigger than 1 kg. If you see the power of 10 in negative, it means the object is lesser than 1 kg. Whenever you see negative, you should understood that is less than, and when you see positive, you should understood bigger than. So it is a bigger than 10 kg, it is less than 10 kg. How less it will be? That will be more than the number. Is that clear? Okay. Then now we'll talk about the second one, that is called charge. Okay, let's talk about charge. Like mass, that everything has mass. Okay, few things might not have mass also. Most of the things have mass. Like that, everything has charge also. Okay, not everything. Few things have charge. Like mass, few things have charge. Somebody might not have charge. Somebody may have charge, but it is zero. There is difference between no charge and charge zero. First, charge is like mass. Somebody may have charge, may not have charge, or have charge, that is zero. Okay, charge is two types. One is positive charge, one is called negative charge. Whatever has charge, it will give you shock. That will conduct electricity. Whatever have charge, suppose this marker, if it is charged, if I can't touch it, it will give me shock. So it has zero charge. It has charge, but its charge is zero. But when I say no charge, that is different thing. Okay, have charge, that is zero. No charge or have charge, there are two types, positive and negative. That means somebody might have positive charge, somebody might have negative charge, somebody might have no charge, or somebody might have zero charge. Is that clear? Okay. Now what is the SI unit of charge? How is to measure charge? Like mass we measure in kilogram, charge we measure in coulomb. Okay, so it is also SI unit. It is also SI unit. It is measured in coulomb. Coulomb is the name of a scientist. So giving him respect, the unit is called coulomb. Okay. So here also, like mass, here also if somebody writes 2 into 10 cube coulomb, and somebody writes 2 into 10 to the power minus 3 coulomb. Here you see it's coulomb. So 10's power is positive, that means this value is more than 1 coulomb. And here it is negative, you should understand this value is less than coulomb. This value is less than coulomb. This value is more than coulomb, means 1 coulomb. It's more than 1 coulomb, it's less than 1 coulomb. Whenever you see negative power, you should understand that is a small thing. When you see positive value, it's a bigger thing. Is that clear? Okay. Next, we'll talk about forces. Let's talk about force. What do you mean by force? Force means adhesive. You used to use gum, Fevikwik, okay, used to use Fevikwik also. This type of gum, adhesive, is called force. There are two types. One is seen, one is unseen. Okay, what is unseen? Okay, seen is Fevikwik, you can say. What is that unseen is? Unseen means like that you get afraid of your father, you want to go out for a movie, Puspa 2, okay? But what happens? Your father has said you not to go. So though you want to go, you can't go. He hasn't bind you with rope in your home, still you can't go. Why? There is a fear. That is also a type of force. Like magnet, it attracts like iron-like things. You can't see that how it is attracting. Thus it sticks on that magnet. That force is also unseen force. Like that, in nuclear science, chemistry, we have forces that we can't see. Obviously, I have said you already that chemistry is science of unseen things, which we cannot see, microscopic things. So the force also applicable here will be unseen one. Like here I said, no? Okay. The most powerful force of whole in this universe, which is unseen, okay? You cannot see like that. That force is called nuclear force. Okay, nuclear force is applicable whether somebody has charge or uncharged, doesn't matter. Any two microscopic objects which are situated very nearby, then they will be bind with Fevikwik like gum. That is nuclear force, which is the most powerful one. So you cannot just stick it out. It will stick it in such a strong way that you cannot separate it. That is called nuclear force. It is the attractive force. Okay. Second one, that is called electrostatic force. Here, it matters only charged particle who have charge, only particles who has charge, whether positive, whether negative. If it has charge, then there will be also a force between charged particle. Okay, that force might be attractive force, that might be a repulsive force. Here, nuclear force is only attractive force, and in electrostatic force, there are two types, maybe repulsive, maybe attractive. Is that clear? Okay. This force is the second highest force. This applicable to only charged particle. Remember, only charged particle. I am talking about microscopic objects. Third one is intermolecular force, that it is also an attractive force, but doesn't matter whether charged or not. It will be between atoms and atoms, or molecules and molecules. It is very weak force. It was discovered by van der Waals, a scientist name. This was discovered by Coulomb, so it's Coulomb force. This force is very weak, is the weakest one. Even weaker than our gravitational force, very weak. Even if you blow it like that, it will break it up. Is that clear? Okay, so let's now start about the chemistry part. Okay, let's talk about now chemistry. So whenever we break up anything, you keep it, break it down, breaking it up. How will you break it up? By hitting it with a hammer, right? When you keep on breaking it, it will first become dust particle. Up to that you can see. Dust particle, up to that you can see. But beyond dust particle, can you break it up? We can't. But under high power electron microscope and very high sophisticated equipments, we can break it beyond this dust particle also. So that one you can't see. You have to see inside a high power electron microscope. Then if you keep on breaking it, last a state will found that beyond that you cannot break it up. That last part, that is called atom. That is called atom. Okay. Like that, if you break it a house, first when you break the house are different types of houses are there. RCC type, Assam type. Somebody have small one. Even the toilet or bathroom is also a type of house. A house may be different, a bigger one, a smaller one, round shape, whatever shape. When you break a house with a bulldozer, okay, so what happens? First you will get the walls. If you keep on breaking the walls also, what you will get? You will get the bricks. So the bricks is the atom. Just I am giving one analogy, okay? So how the bricks is made up of? Bricks is made up of sand, soil, okay, and mud. Like the atom also is made up of three things. This is the structure of atom. Inside, zooming it out inside, where? High power electron microscope. This is the enlarged and zoomed view of an atom, because you can't see atom. It is beyond our capability, beyond even the simple microscope. It should be a high power microscope. So it is zoom view, okay? This is the atom. So in atom there is a center place. Like that in our place we used to have a center place where people used to gather, their shops are there. Okay, these people used to buy things and all. People used to gather, all the people used to gather there, have a tea and like that. Like that in an atom also there is a center. And the word center, in Greek language, that word center means nucleus. In Greek language we don't say center, we say nucleus. So this is called nucleus. Inside the atom, already atom is very small one, more smaller part means 1% part of an atom is called nucleus. Inside nucleus, there are two subatomic particles. One is called proton. Okay, inside nucleus, there are subatomic particles. Like that, inside a brick, what is bricks are made up of? Dust, soil, and mud. Like that, inside the atom, there are three subatomic particles. One is called proton. That is here, these are proton. The blue one you can see, these are protons. And these are neutrons. Neutrons, name of subatomic particles. And these red ones are electrons. It's already red. These are electrons. So there are three types of subatomic particles. That is, an atom is composed of. One is called proton. Proton has mass also. Proton has charge also. And proton has positive charge. I said no? Charge are two types. Proton has positive charge and proton has mass also. Okay, proton mass. How much is proton's mass? Proton and neutron, they have equal masses, about equal masses. The mass is 10 to the power minus 27 kilogram. You see, 10 to the power minus 27. That means so small. And neutron also has equal masses. But neutron doesn't have charge. Proton has positive charge. Okay, how much charge proton has? Proton has 1.6 into 10 to the power minus 19 coulomb. So see, it is very, very, very less than 1 coulomb, minus 19 coulomb. One proton has this much charge. The type of charge is positive. A neutron has mass. The mass is also same, but it doesn't have any charge. And they are inside the nucleus. How? Why they are inside nucleus? How people are in the center place? Why not they are going here and there? Because here these particles are very nearby and they are microscopic particles. So the highest adhesive, that is called nuclear force, it is binding them together. A very powerful glue, or that is like Fevikwik. So it is binding them together. So next one, number 2, proton. Proton has positive charge. Proton and proton, positive, positive. And I said you number 2 force, that was electrostatic force. So electrostatic force, what happens? If they are same type of charge, they will repel each other. They will pull it out, hey, go like that. They don't like each other. Still they are together. Why? Because they are bound by this strong nuclear force. Though they don't like each other, they will push each other. Still they are holding together. Why? Due to that strong nuclear force. And electrons. Electrons have mass of minus 31 kg. That means they are much more lighter than this proton. Proton has minus 27 and electron has minus 31 kg mass. That is very, very, very light. And they have charge equal. They have equal charge. They have equal charge like proton, but they are much more lighter than proton. Okay. That is why we know lighter objects are there as they are light. They used to go here and there. The body is free. We used to jogging and all to become light, to decrease our weight, so that our body will be free and we can roam here and there. The electrons are like that. They are very free, so they want to go here and there. They don't want to stay in one place. They will try to go here and there. Whereas the proton, as they are stick together with the nuclear force, and they are heavy also, so they are lazy like people. They don't want to go. If they want to go also, they cannot break it, that Fevikwik force. That is called nuclear force. So they will not go out. But this electron, they want to go out. Then why not they are going out? Because the second powerful force, that was, what was that? That was electrostatic force. Due to that force, proton and electron, this is positive and negative. It is also charged, it is also charged. So between proton and electron, there will be electrostatic force number 2, second strongest. So it will just hold it, though it want to go there and here and there, it will pull it in towards the center, towards the nucleus. So they don't want to go that side. Due to this pull, they will ultimately revolve around the nucleus. Actually, they are not revolving themselves, but due to that attractive force, they are bound to revolve around the nucleus. Okay, that is all about for today's class. So if you want to get more classes like this, you have to visit my next class that will be based on why, how and when these atoms together join, what forms molecules like compounds, elements, etc., etc., different types of equations and all. If you want to go a ground zero concept for that, so you have to follow my Manoj Masterclass tutorial classes. Okay, if you like it, then you can subscribe. This is up to you totally. My thing is that your concept should be clear. So if you like it, please subscribe and share. It is up to you, but don't forget to watch my video, pause it, repeat it and watch it. I'm sure your basic concept about this atomic structure will be clear. So hope I'll see you in my next class. Tata and bye-bye.